To make sense of what an atom is and what is representing and what type of atom we are looking at, we need three pieces of information. The first one we need its atomic symbol, which is what represents that particular, what type of atom we are looking at, what type of element we are looking at. So the H is the symbol for hydrogen, so we know it's a hydrogen atom. Cl is the element chlorine. Na is the element sodium. And you find those, for example, in a periodic table. The next piece of information we need to know is how many protons you have. And that's what we call the atomic number. So atomic number, and the typical letter to signify atomic number is Z, is the number of protons in that particular atom, in that particular element. And the number of protons is unique to each element. So we define each element with respect to its atomic number. So the element that has atomic number 1, that has 1 proton in the nucleus, we call it hydrogen. There is an element that has 2 protons in the nucleus, atomic number 2, and we call that helium. We have an element that has atomic number 6, it has 6 protons in the nucleus, and we call that carbon. So the atomic number determines what element you are looking at. So of all the atoms you can have, which one, to what type of element, to what element it corresponds. And then we have the mass number. And the mass number is the combination of the protons and the neutrons in the neutrons in the nucleus. And we will see that the number of protons, yes, is determined by what element you're looking at, but we will see that the number of neutrons varies. So for example, I've got here the example of the high H with 2 ones, one as a subscript and the other one as a superscript. Well, H is a hydrogen atom, and I know that because the symbol H represents hydrogen. The number at the bottom is the atomic number, and it's 1, and that means that it has 1 proton. And the number at the top, the superscript, is the mass number, and that's also 1. And that's the number of protons and the number of neutrons, because I know from the atomic number that the number of protons is 1. That means that hydrogen that does not have any neutrons, and I know the number of protons, the number of electrons, because I know that atoms on their own are electrically neutral. So if it has 1 proton in the nucleus, it needs to have 1 electron in the electronic cloud. We have another atom here which has a mass number of 12, an atomic number 6, and the letter C. Well, the letter C represents the element carbon, so I know it's a carbon atom. The atomic number is 6, and that tells me that the carbon atom has 6 protons. I know that atoms not interacting with anything, are neutral, so this carbon atom has 6 protons, therefore it's going to have 6 electrons. And the mass number is 12, and that means that because it has 6 protons, 12 minus 6 is 6, it must have 6 neutrons. So that this symbol here, this represents a lot of information that I can get from my element. What type of element, or from my atom, what type of element it is, how many protons, neutrons, and electrons it has. So now I'm going to ask you to stop the video and do this exercise. If you have an atom that has an atomic number 17 and a mass number 35, could you calculate, or can you determine how many protons, neutrons, and electrons it has? And if you feel like it, and you have a periodic table near you, what element I'm talking about? Hopefully you stopped the video and had a go at the exercise. So how would I go about doing this exercise? Well, I know that the atomic number for my element is 17, and that immediately tells me how many protons I have, 17, because that's exactly the definition of what atomic number is. I also immediately know, because I know the number of protons, and I know that the element, when an element is on its own, is not interacting with anything, it's in neutral state, how many electrons does it have? It needs to have 17 to counteract these 17 positive charges. And then, how can I determine the number of neutrons present? Well, because I have the mass number, I know the mass number is the number of neutrons and the number of protons. So if I know the number of protons, which are 17, and I know that in total I've got 35 as the mass number, that gives me a total of 18. So my element has 17 protons, 17 electrons, and 18 neutrons. And if you have a quick look at the periodic table or a quick Google, you might have found out that the element I'm talking about is chlorine, chlorine 35. Again, I'm going to ask you to stop the video and do this exercise. You have an atom that has an atomic number 11 and a mass number 23. And again, I'm asking you the number of protons, neutrons, and electrons present. And I'm going to ask you that you go and find out which atom do I have in mind, which element we are talking about. Stop the video now. So hopefully you stop the video and have a go at the exercise. So again, atomic number 11, atomic number is defined as the number of protons in the atom. So that means that I have 11 protons. An atom, an element which is not interacting with anything, is on its own, is neutral. So that means that those 11 protons is to be compensated by 11 negative charges, 11 electrons in the electronic cloud. And finally, I use the mass number, which is the number of protons and the number of neutrons. So since I know that my mass number is 23, and that equates to 11 plus the number of neutrons, the number of neutrons needs to be 12. So my element, my mystery element, has 11 protons, 11 electrons, and 12 neutrons. And again, if you have a look at the periodic table, you might hopefully you have discovered that the element I have in mind is Na, sodium, a sodium atom.